Okay, for number 9, it says a person at the top of a lighthouse spots a boat approaching the lighthouse at a 10-degree angle of depression. Excuse me. If the lighthouse is 200 feet tall, find the length of the line of sight from the person to the boat. Okay, so I'm an amazing artist, as you know, just kidding. Here's my person that's in the lighthouse. We'll say this is the lighthouse here. And they're looking out and they're seeing a boat somewhere out here in the water. Now, whenever you do angle of depression, these can be kind of tricky. So an angle of elevation or depression has to come from if the person or object or whatever were to look straight ahead, and then they have to either curve their eyes up for angle of elevation, or in this case, curve their eyes down for angle of depression. So this is definitely not drawn to scale, but the person is looking down here at the boat. So the angle would be here. Okay, now we're going to go ahead and assume the base of the lighthouse is going to make a right angle with the water here. And then it says the lighthouse is 200 feet tall. So this is going to be our 200. And we want to find the length of the line of sight from the person to the boat. So the line of sight, if you ever see that description, that is always the hypotenuse of your triangle. So the line of sight would be the hypotenuse there. So what we want to do for that, the 200 is going to be this side. I don't actually have the angle, and I did a really bad job drawing this, but the angle of elevation and the angle of depression between the same two objects would be the same. So horizontal line here, horizontal line with the water. Pretend I drew this better. But this angle and this angle are always the same between the same two objects. They're alternate interior angles. So what I want to do here is look at the angle in my triangle. So the lighthouse is opposite that. And oh my goodness, the line of sight is always your hypotenuse. Sorry, I'm getting ahead of myself. Opposite hypotenuse is going to be sine. So I'm going to do the sine of 10 degrees. The side opposite is the lighthouse, and the line of sight is the hypotenuse, and that's what we're trying to figure out here. And so what we want to do is go ahead and use a sine here. Now, if the variable's in the denominator, which it is, we're going to trade places. So x is going to be 200 divided by the sine of 10, and that'll give us the line of sight from the person to the lighthouse. Or sorry, to the boat. All right, to approach a runway, a plane must begin a 9-degree descent starting from a height of 1,125 feet. So again, forgive, here's my plane, and we're gonna have them, if they look straight ahead, it's a horizontal, we're gonna come down, again, this is not drawn to scale, at a 9-degree angle. And they're at a height here, which is going to make a vertical line with the ground, 1125. All right, to the nearest tenth of a mile, how many miles from the runway is the airplane at the start of its approach? So how many miles away from the runway? Now, little trick here. The question is in miles, so we need to do a quick conversion to answer the question there. And you see that I wrote there that 1 mile is 5,280 feet. So I'm just going to grab my calculator here real quick. I need to convert this 1125 feet into miles. So I'm just going to take 1125 and we're going to divide that by 5,280 because that's how many feet are in a mile. So it's not a mile there. If I divide that, and you guys can see I got a decimal when I did that, and we can write our answer in miles then when we're ready to go. The other thing we could do, instead of converting here, I can get my answer in feet to start out with and then convert that at the end. So that's up to you. Either way will work. And we're finding the distance the plane is going to travel to the runway, so that would be here. All right, super similar to the last question. The 9-degree descent angle here is not actually inside my right triangle, but I can use alternate interior angles here. The ground and the pilot looking straight ahead would both be horizontal lines, so these create alternate interior angles with that hypotenuse of the triangle being like a transversal. So this is going to be 9. Now here, and actually this is very similar to the last question, I'm going to do the sine of 9, and that's going to be equal to the opposite, which is the 1125 over the hypotenuse, which is what we're trying to find there. These are going to trade places, and so the hypotenuse is going to be 1125 divided by the sine of 9. Now I'm going to work this one out so you guys can see the conversion here. Now I went ahead and left that in feet, so I'm going to do 1125 divided by, now my calculator on the computer here, I have to, if I'm going to do a sine, cosine, or tangent, type the angle measure first, so this is a little different than the calculator. So I'm going to type 9 and then the sine, and you'll see that does the sine of 9 there for me. I'll go ahead and hit equals, and this is going to give me the answer in feet, so we'll have to do a quick conversion. So the 7191.5, and you guys can see the rest of the decimal. That's what it would be in feet. To convert it to miles, I'm just going to divide that by 5,280 to get my answer, so I'll just leave it right there on the calculator screen. Divide by 5,280. This will put it in miles instead of feet. And so approximately, let's see, it says to the nearest tenth of a mile, so about 1.4 miles would be my answer for that question. All right. The problems right below here, they're basically sine, cosine, and tangent questions that are already set up for you. They don't have a picture. We just have to solve them. So I'm just going to go through real quick. This is just going to be typing information into your calculator. So cosine of 48 is 10 over x. If the variable's in the denominator, these trade places. So to solve this question, you want to do 10 divided by the cosine of 48 on your calculator. For this question, I don't know the angle, so I'm going to do an inverse here. So this is going to be inverse sine 49 over 73. And then the last one, I've got the variable in the numerator with the tangent here, so I'm going to multiply both sides by 125 to get that answer, and you guys can type those in. For number 12, we're just going to sketch a vector. Now, whatever word comes second, that is the axis that you want to start on, and we're just going to kind of ballpark these as we go, so it doesn't have to be perfect. Now, the first one says 30 degrees east of south. So I want to start on the south side and go east of that, right? Here's the south, go east of that. The angle should be between the south axis here and the east side. And I'm just going to kind of, estimate here. Exactly halfway in the middle would be 45 degrees. So I'm going to go less than halfway here to kind of estimate that, put the 30-degree angle, and that measures from the south to the east, so east of south. 45 degrees north of west, start on the west side and go north of that. 45, the best I can, I'm going to draw directly in the middle there, and it should have a 45-degree angle between the west side and the north here, and I'm just drawing that I'm going north from the west side. And I got one more, west of south, so we want to start on the south side and go west of that, 60 degrees. So 45 is halfway, so I'm going to try to go more than halfway. It doesn't have to be perfect. I'm just looking for the angle measurement in here, and I'm going west from the south side, so the angle would be there. Number 13 says describe the vector in component form. So what you want to do is tell me what point is that vector pointing to, and they actually have this labeled for you. The x-coordinate of this point would be what you do to travel to the right, the y-coordinate what you do to travel down. That creates a right triangle. Okay, now the one tricky part to these questions, let me just do one at a time. I have the magnitude, that's 96, and I have the angle measurement here. Direction for this vector would be 48 degrees south of east here, if we were describing that. If I want to find x, I'm going to go ahead and use the magnitude and the angle there. Adjacent hypotenuse, I'm going to do cosine 48 is x over 96. To solve that, I'm going to multiply both sides by 96. And I'm going to go ahead and do that on my little calculator on the computer here, sorry. So we're going to do 96 times, and remember on mine I just have to type the angle measure first, the cosine of 48, and you can see that up there. I'm going to go ahead and hit equals, and we're going to round this to the nearest tenth. So x here is going to be about 64.2. Now I'm going to redraw that triangle, which you don't have to do this, but I want to do y as a totally separate problem here. The y coordinate of this point from this angle, this is going to be opposite hypotenuse. So I'm going to do sine of 48 y over 96. So very similar problem. I'm going to multiply both sides by, 96. I meant to type that into the calculator. So I'm going to do 96 times, again, I have to type the 48 first, and I'm going to do the sine of that. And that's going to give me 71.3. Okay, now the only thing you have to do when you write your components to be careful of here, look where is the vector in the coordinate plane. So here I am going over to the right and going down. So the x coordinate should be positive and the y coordinate should be negative. If you have a negative coordinate, you're going to have to be mindful of that because we're using right triangle trig to find those distances, but you might have to put a negative into the problem to answer the question, which is what I do have to do here. So my answer for this, the x value would be positive because I'm going to the right, but this y value, I just need to put a negative in front of it because that is going down 73.1 to place that in the coordinate plane. So those would be your components. All right, another vector question here for number 14. Graph the vector. Here's the components, -7, -4. You're going to plot that just like you would plot a point. So I'm going to go over 7 to the left and down 4. That would be this point right here. The vector should come out of the origin and point to that coordinate. Find the magnitude of the vector and then the degree and direction with the x-axis. To do that with the x-axis, what I want to do is I'm just going to create a right triangle here by connecting that vector to the x-axis. I'm going to use the x-axis here as the other side. Just going to connect that. That creates a right triangle. Now, in terms of the magnitude is the length of the vector. So even though I'm doing a -7 to get to this point, the distance is 7. And I'm doing a -4 to come down here, but the distance is 4. So to do your magnitude, just do a little Pythagorean theorem. So it's going to be 4 squared plus 7 squared magnitude squared. This will be 16 and 49. And then we'll just have to take the square root when we get done with this. And so I'm going to have 65 being my magnitude squared. And we'll just take the square root there. So let me pull up that little calculator here again. And I'm going to do 65 and take the square root of that. And to the nearest tenth, I would say that is about 8.1 for my magnitude. Okay. The second part of the question asks you for the degree measure. So the degree, we want to find this angle measurement here. So I'll tell you what, let me just call that x. Now, the magnitude I rounded, so I don't want to use the magnitude. What I would recommend using is just go ahead and use the 4 and the 7 because those are nice numbers there. And so 7, 4, here's my angle. 4 is opposite, 7 is adjacent, so I'm going to do a tangent to figure this out. And we'll do an inverse tangent. So I'm going to cancel the tangent out doing that. So I'm going to do tangent inverse here. And once I do that, I'm going to grab that calculator again. Again, sorry, you guys, this calculator on the computer is a little backwards. So I'm going to do 4 divided by 7. And I need to do the inverse tangent of that. So that's just that second tangent. And you can see I've got that there. And oops, I just divided that by 7 again. Sorry, let me fix that. So it was what it was originally up on the screen there. So that's going to be rounded to the nearest degree. That's actually going to have to round up to 30 degrees. And then if you look back at the problem, to get to the vector, I'm starting on the west side and moving down. So this would be south of west for your direction there.